Welcome back. Today, we're looking up at the sky and talking about one of the oldest, most established forms of renewable power on the planet. I mean, when we think of wind power, our minds naturally jump to those massive offshore wind farms, right? Or those sprawling plains of giant, towering turbines dominating the landscape. But we're going to do something a bit different in this explainer. We're taking that massive grid powering technology and literally scaling it all the way down for your very own backyard. So here's the big question. Can you actually power your home with a breeze? Can we take the concept of those massive highway wind turbines you drive past on road trips and completely recontextualize them into an accessible residential energy solution? Well, if you're looking to reduce your reliance on the power grid and lower your carbon footprint, you are definitely in the right place. Okay, let's dive into this. Here's our roadmap. First, we'll meet residential wind power. Then, 2 ways to catch wind. Third, wind energy versus solar. Fourth, what to know before you install a turbine. And finally, the ultimate hybrid energy setup. Section 1. Meet residential wind power small wind systems. Now, for homeowners looking to really take control of their grid reliance, these small wind systems are just a fascinating option. And this brilliantly illustrates the electrical output we're talking about. These setups typically generate somewhere between 1 and 10 kilowatts of power. Where you fall in that range, well, that depends entirely on the size of your home and your specific day-to-day energy needs. But this 1 to 10 range is basically the sweet spot for keeping a standard house running smoothly. The mechanics behind how a literal breeze outside transforms into, say, a running refrigerator inside, they're beautifully simple. Step 1, the wind blows, which turns the aerodynamic blades of the turbine's rotor. Step 2, that spinning rotor connects to a generator, and that converts the kinetic, mechanical movement directly into raw electricity. Step 3, that raw electricity is routed through an inverter so it perfectly matches the electrical current your house actually uses. And finally, Step 4, it powers your life. It runs your appliances, your lights, and your HVAC systems seamlessly. Moving on to Section 2, 2 ways to catch wind. Choosing your turbine design. So, when you're choosing a turbine, you essentially have to pick between 2 primary designs, and they're categorized entirely by the orientation of their rotating shaft. First up is the horizontal axis wind turbine, or HAWT. This is that classic windmill design you're probably most familiar with. The rotor shaft and the electrical generator sit way up at the top of a tower, and the blades spin on a horizontal axis. Now, these are incredibly efficient at capturing wind energy, but because they absolutely must face directly into the wind, which is usually handled by a tail vane, and because they need access to stronger, smoother winds, they require a very tall tower. That height is critical just to clear the ground-level turbulence caused by stuff like trees and buildings. On the flip side, we have the vertical axis wind turbine, or VAWT. These have a main rotor shaft set vertically, so they often look like giant egg beaters or swirling cylinders. Unlike the horizontal versions, these are omnidirectional. They don't need to pivot to face the wind. They just catch it from literally any direction. This makes them perform incredibly well in the turbulent, shifting winds you typically find in suburban environments. Now, while they are inherently a bit less efficient overall because they sit closer to the ground, they're way easier to maintain. I mean, the generator's right down there near ground level. Now, what's really interesting about this slide is when we put these 2 designs head-to-head, they contrast perfectly based on what you actually need. The horizontal turbine gives you maximum efficiency, but man, it demands large vertical space, a tall tower, and it has to point directly into the wind. The vertical turbine? Well, you give up some of that efficiency, but it rewards you by being omnidirectional, quieter, and totally capable of handling complex suburban air turbulence without needing massive vertical airspace. Section 3. Wind energy versus solar, the renewable heavyweights. For almost every homeowner, the decision to invest in renewables usually turns into a massive showdown between wind and solar. A really common misconception is that they do exactly the same job. But the truth is, wind thrives exactly when solar struggles. Just think about the limitations of solar for a second. It only produces energy during daylight hours, and its output drops significantly during cloudy winters. Wind turbines, though, they generate electricity 24/7. Plus, wind speeds are often higher during the winter and during powerful storms, which just happens to be the exact moment solar panels are least effective. Looking at the big picture here, while wind works day and night whenever the breeze blows, those rapidly moving blades and gearboxes mean significantly higher maintenance compared to solid-state, super low-maintenance solar panels. Furthermore, while solar panels take up a large surface area on your roof or yard, they're pretty widely accepted by zoning boards. Wind turbines, however, have this tiny ground footprint, but their massive vertical height requirements and potential noise often face really strict zoning difficulties. So you're ultimately trading location flexibility for round-the-clock power generation. Section 4. Before you install a turbine, the homeowner's checklist. So the crucial point is that you can't just buy a wind turbine online, stick it in your yard, and hope for the best. The absolute first thing you need is an average annual wind speed of at least 10 to 14 miles per hour to make a residential wind system economically viable. Without this consistent wind speed, the system simply won't generate enough electricity to justify the upfront investment. Okay, let's say you have the wind. Next up, you absolutely must be aware of local building codes. This is where the physical reality of turbines completely clashes with municipal laws. You see, many local municipalities have zoning laws that restrict residential structures to a maximum height of 35 feet. But, as we learned earlier, an effective horizontal axis wind turbine needs a tower of 60 to 100 feet just to clear the turbulent air caused by houses and trees to actually run efficiently. So, here is your concrete 3-point checklist before making a move. First, assess your local wind resources via national wind maps to ensure your average speed is actually high enough. Then, check your local zoning and HOA laws regarding height and noise restrictions before you spend a single dime. Finally, evaluate your physical space. If you live in a dense suburb, a tall horizontal turbine is probably out, and you'll likely need to factor the lower efficiency of a vertical turbine into your overall budget. Let's move to Section 5 and see how this builds. The ultimate hybrid energy setup, year-round resilience. But what if you didn't have to choose between the heavyweights? Enter the hybrid system. This is basically a microgrid that combines the daytime plug-and-play reliability of traditional solar panels with the nighttime and storm weather generation of a small wind turbine. By putting both on your property, you create a highly consistent, year-round renewable energy microgrid. It's truly the absolute pinnacle of an off-grid, highly resilient setup. It really all comes back to this core thesis. Wind energy fills the gaps where solar falls short. Solar power definitely remains the easier, lower-maintenance option for the average suburban home. But for homeowners with larger properties in breezy, rural, or coastal areas, wind energy perfectly completes the puzzle, stepping up and taking over during the dark nights and those short, cloudy days of winter. So I leave you with this final provocative thought to ponder. Does your property have what it takes to build the ultimate hybrid microgrid? I invite you to step outside today, check the breeze in your backyard, look at your available space, and really envision what true, year-round energy independence could look like for you. Thanks for joining me for this explainer, and as always, keep learning.